Welcome to the world of immunology. I'm Professor Janeway. In this world, we humans utilize different immunoglobulins to combat antigens. To get you started, let's dive into an overview of what the immunoglobulins do.
Immunoglobulins, or antibodies, provide one of the body's main defenses against foreign invaders. Antibodies are structurally related but display nuances that define their class, subclass, and antigen specificity. These Y-shaped proteins have a relatively conserved Fc region that defines antibody class and function, and two identical Fab regions that determine the molecule's precise epitope. Fab and Fc regions are separated by a flexible hinge region that allows immunoglobulin molecules to accommodate different antigen configurations. Let's look at antibody structure in more detail using the most abundant Ig class in serum, IgG. IgG is a 150 kilodalton protein comprised of two heavy and two light chains held together by interchained disulfide bonds. Antigen specificities are generated by the rearrangement of germline B-cell DNA, and similarly, antibody classes arise through class switch recombination. The IgG class in particular exhibits four subclasses, IgG 1 through 4, each encoded by a unique C-gamma exon and directed by their own S-gamma switch sequence. Differences in hinge region length or number/location of disulfide bonds also generate different effector functions between subclasses.
Well, hello there, young trainer. What can I do for you?
Yo, Professor Man. I'm here to explore the wonderful world of immunology.
Of course, here are your starters. 4 IgGs.
Thanks, homie. I'm about to take these anti-baddies into the wild. Whoa, what's that? It must be a hepatitis Z virus. IgG1.
IgG1 is the most abundant IgG subclass, making up 65% of total IgG at a serum level of 6.98 grams per liter, so selective IgG1 deficiencies often cause hypogammaglobulinemia and recurrent affections. IgG1 has only two inter-heavy chain disulfide bonds, offering flexibility to the 15 amino acid hinge region. The IgG1 Fab region specifically binds soluble and transmembrane protein antigens, while the IgG1 Fc region can engage all human Fc receptors. This widespread compatibility enables broad effector functions, including the release of inflammatory mediators and immune cell activation, enhanced phagocytosis by opsonization and agglutination, and finally, complement-dependent and antibody-dependent cellular cytotoxicity. However, IgG1 is most important in antibody responses against viral pathogens.
Nice, we won.
Hey, stop right there. Let's battle.
You're on.
HIV, I choose you.
HIV, pathetic. IgG3, I choose you.
Despite being present at low concentrations, making up 4% of total IgG, the IgG3 subclass serves as a strong pro-inflammatory antibody responsible for mediating the induction of various effector functions. Perhaps most important, it plays a role in the activation of complement, specifically through the classical pathway via binding to C1q. It is characterized by a long hinge region spanning up to 62 amino acids, providing considerable flexibility. This has various implications on antibody function, such as its antigen binding capacity and the movement of its Fab and Fc regions. Moreover, a study conducted by Chu et al. On HIV-specific IgG3 antibodies demonstrated that the hinge region may be involved in increasing phagocytic activity. Lastly, its relatively short half-life of approximately 7 days has been proposed to regulate excessive inflammatory responses.
Damn, bro. You really know your IgG subclass antigen interactions.
Thanks, man. I paid attention to lecture 4 of Imm340. You should too. Now where's that gym leader? Gym leader, I've learned a lot about my IgG subclasses so far.
Pathetic. I have learned to harness the power of the pathogens to infect and trigger immunogenic responses. Your journey ends here. Hellman, go get him!
Oh my god, a Hellman. IgG4, I choose you.
IgG4 is the least abundant subclass at 4% abundance and a serum level of 0.58 grams per liter. It has two disulfide bonds in its hinge region, and has a hinge region that is 12 amino acids long. IgG4 is usually produced after chronic exposure to an antigen. Allergens that have been chronically exposed are the most common antigens. This is thought to be due to the fact that the C-gamma4 cassette is more terminally positioned than the other C-gamma gene regions. Helminth or filarial parasite infection may also result in an IgG4 antibody response. IgG4 has a number of anti-inflammatory features. It has low affinity for Fc gamma receptors, it cannot fix complement, and it competes with IgE for allergen binding, blocking IgE functions. It also suppresses mast cells and basophils by cross-linking Fc gamma R2b and Fc epsilon R1 with IgG4 and IgE. IgG4 also undergoes Fab arm exchange, where half of IgG4 molecules recombine with the other half of IgG4 molecules at random. The resulting bispecific antibodies have a decreased avidity.
Impossible! My Helminth was unstoppable. Fortunately, I still have another at my disposal. Streptococcus pneumoniae, I choose you.
Haha, this should be easy. IgG4, come back. IgG2, I'll use you instead this time.
IgG2 is found at relatively high concentrations, 32% of total IgG, making it second only in abundance to IgG1. Due to alternative disulfide bond formation, IgG2 exists as several isoforms that differ in their structural hinge regions. The A form is characterized by 4 disulfide bridges between the 2 heavy chains, while the B form is distinguished by the formation of a disulfide bond between a hinge cysteine and the light chain. Despite this variability in their structural hinges, Fc receptor binding remains the same across all isoforms. IgG2 responds strongly to bacterial capsular polysaccharide antigens, playing an integral role in the body's immunological response to bacterial infections.
Ow, good to see you.
Professor, my IgG2 failed. What's happening?
IgG2 is the most common subclass deficiency. Let's see if your IgG2 is still working.
This IgG2 has a frameshift mutation caused by a single base insertion. There's an extra guanine at the 1793 position in the C-gamma2 gene. Study by Terada and others called Fate of the mutated IgG2 heavy chain found this mutation in a pair of siblings in 2001. They hypothesized that this mutation resulted in an IgG2 serum level under detection limits due to one of 2 reasons. First, the frameshift mutation resulted in its loss of function as a BCR that then cannot be expressed on B-cell surfaces, or second, the frameshift mutation resulted in a loss of an evolutionary conserved motif that made it able to be expressed as a BCR, but unable to complete signal transduction. They found the mutation in the IgG2 heavy chain made it unable to be expressed on the B-cell surface. They also found that this surface expression is necessary for the secretion of soluble IgG2.
That does not sound fun. Looks like we still have a lot of learning to do.